Hello everybody, welcome to my math channel. I hope you are all doing okay. Today we will continue studying chapter 9 and the lesson I'm about to explain is lesson number 2, angles and angle measure. So be ready everyone with your books, notebooks, pens and calculators, and let's start our lesson. Point number 1, angles in standard position. What is the angle in the standard position? The ray on the x-axis is called the initial side. This ray is always fixed on the x-axis and is called the initial side, means it's the start. And the ray that rotates about the center is called the terminal side, this one. The terminal side that can go this way or it can go this way. The vertex must be exactly on the point of origin, the intersection of the x-axis and y-axis. If this happens, we say that this angle it's in standard position. Now, this angle is in standard position. It moves counterclockwise, that's why it's positive. This angle also it's in standard position. It moves clockwise, that's why it's negative. So, if we have an angle moving the same as the clock, it is negative. If it's counterclockwise means it is positive. Now, if we ask you to draw an angle with the given measures in standard position, for example, the angle 215, it's positive, so it moves in counterclockwise. It will pass 180 by 35 degrees. So you come to the second quadrant and you draw the initial side. Draw a measure of angle negative 40. Negative 40 means it moves clockwise. So draw the initial side fixed on the positive x-axis, and the terminal side will be in the fourth quadrant because we are moving clockwise. Now it's easy for you to graph those. This is angle 80. How can you graph the angle 80? You will draw the x-axis. You will draw the y-axis. And the initial side is fixed on the positive x-axis like this. This is the initial. Now we need the terminal to be 80. So 80 nearly is like this one. No need to take a protractor and so on. Just draw it this way and show me that it goes from this way to this way, and you write here 80 and that's it. Now if we want to graph this one, the same, draw the x-axis, draw the y-axis. Of course you need to use your ruler for your graph to be neat and accurate. Now negative 180, so we are moving in the other direction, means in clockwise direction, this way. So let's draw the initial side first. This is the initial side, and the terminal side will move this way in this direction. If it reaches here, it's negative 90, but we need negative 105, so it will be here nearly, and you should show the direction this way, and you write this is 150. Of course it is in negative, so negative 150. As you can see, the first example is very easy, just to graph. Now, moving on. Another idea, How can we graph an angle of measure greater than 360? And what quadrant it will be? For example, this angle is 480 degrees. And you know that 480 is like a full rotation of 360, and in addition 120 degrees. So it will be in the second quadrant, because as if you are drawing 120 degrees. But you need to show me that really it is 480 by doing this spiral, means a full rotation that in addition 120 degrees. Let's try to draw this one. Draw an angle in the stand-up position that measures 600. 600, you know that 600 is like 360 and in addition 240. Now how can we draw? Draw the x-axis, draw the y-axis, draw the initial side. You know that the initial side is always on the positive direction of x-axis. Now you need to show me that it's really make a full rotation. It makes a full rotation and in addition 240 degrees. Let me show you how you can express this. Very easy and simple. Let's say that it will make, come closer to the zero. Yes, it will make like this, a full rotation. This is a full rotation, right? Now let's continue 240 like this, 180, that in addition another 60 degrees this way. Now you draw the line. Let me draw the arrow to show the direction. Then let me draw the arrow that will show the terminal side this way. So you are going to explain your drawing that this is 300 till here. It is 360. And the rest is 240 on this line. So it's easy to graph an angle measured greater than 360. Now the coterminal angle. What does it mean, the coterminal angle? Coterminal angles means angles they have the same terminal side. Like those angles. If you draw angle 60 or you draw the angle 420, because 420 is 360 plus 60, or you draw the angle negative 300, because negative 300 also will reach exactly at the same position with 60. All these angles, they have the same terminal side. That's why we say they are coterminal angle. Coterminal means they have the same terminal side. Now how can we find coterminal angles? For example, find an angle with a positive measure and an angle with a negative measure that are coterminal with each angle. The idea is very simple. Take the given angle, like 130, add 360, then subtract 360. So if you add 360, it's 490, means it's positive coterminal angle. If you subtract 360, it will be negative 230, means it's a negative coterminal angle. The same will happen here. Add 360, subtract 360. If you add, so it will give you 160. This is a positive coterminal angle. If you subtract, it's negative 560, so it's the negative coterminal angle. Now let's do it here in the 15. For the 15, so 15 plus 360 will give you 375 degrees. This is a positive coterminal. 15 minus 360. This will be negative 375 45. So this is a positive coterminal and this one is the negative coterminal. Now, how can we do it to this one? I have negative 45. Let's add 360. This will give you positive 315 degrees. Now, the negative 45 minus 360. This will give you negative 405 degrees. See how easy? So coterminal, add 360 or subtract 360 according to the required. Sometimes we only ask for one. Just find the positive. Just find the positive. So add. Just find the negative. Subtract, and so on. Now this was example 3. Moving on. Before we discuss example 4, we need to know two important rules. How can we convert between degree and radian measure? We have another type of course we are familiar with the degree measure, but we need to know what is the radian measure. It's another type of measure that we can consider the whole circle is like 2 pi. So 2 pi in radians is equivalent to 360 degrees. And the pi in radians is equivalent to 180 in degrees. So now, how can we convert? You need to memorize these two rules. This will not be given in the exam. So, if you want the radian, this is your aim, the radian. You have the degrees and you need the radian. Multiply times pi over 180. Pi over 180. Now, if your aim is to find the degrees, this is your aim. From radian to degrees means I will give you the radian and I'll ask you for the degrees. So you need to put the degrees up. 180 degrees over pi. So just put this in mind. You need the degrees, you put the degrees up. You need the radians, you put the pi up. And so on. Example 4. Guided practice. Rewrite the degree measure in radians and the radian measure in degree. Means if I give you the degree, you give me the radian. I give you the radian, you give me the degree. Of course, any angle is expressed in pi. In pi, no need to mention it's radian because in pi it's already radian. So 120 in degrees, very easy. Let's remember together the rule. It will be 120 in degrees and I need the radian, so I put the pi up and 180 down. You can use your calculator and it will give you 2 over 3 pi. Leave it like this in pi, or if you want it if we are asking you for an approximated answer, so you will use your calculator and it will be about 2 point nearly if we are asking for this, but sometimes we are asking for the exact. This is the exact answer. The approximated answer, it will be 2.094 and it's in radians. But sometimes it will be better to leave it 2 over 3 pi. This is the exact answer. Now this one is given in pi, means it's already radian and I need a degree. So the rule says you have the radian negative 3 pi over 8 multiplied by 180 degrees over pi. Now the pi with the pi will go bye and fly, so you will have negative 3 multiplied by 180 over 8, and this will give you negative 67.5 degrees. So again, we have the degree, means we need the radian. So we need the radian, we multiply times pi over 180. We have the radian, so we need the degree. We need the degrees, so we multiply times 180 over pi. Moving on. Before we discuss example 5, this is a very important rule. We have a circle. This is the radius of the circle, and this is another radius, so there is an angle between them, we call it theta, and this is the arc between the two radii, it's called S. There is a very important relation between the length of the arc S and theta in radians and R, that is S, the length of the arc equals R times theta. But pay attention, because this theta must be in radians. Theta must be in radians, means if I give you in radian, it's okay. If I don't give you in radian, I give you the degree, you must transform into radian first before you apply the rule, because this rule needs theta in radians. Okay, we can gather this rule in this triangle. This is a very famous triangle. If you put the S up, this is the length of the arc, the R down, and the theta in radians. So if you need the R, it will be S over theta. You need the theta, it will be S over R. You need the S, so R multiplied by theta. Now you can study this example, it's an easy one. Let's go to the guided practice and try to solve it. A circle has a diameter. We have the diameter is 9, means the radius equals 4.5 centimeters. Find the arc length, means we need the S. If the central angle is 60 in degrees, pay attention, so we must to convert. So first of all, we need to find the theta in radians is equal to 60 multiplied by, we need the radian, so we put the pi up over 180. This will give you pi over 3, or third pi. It appears on the calculator, third pi. So you have now theta in radian. What do you need? You need the S. So the S equals R theta, or theta times R, the same. The R is 4.5 or 9 over 2, the same. Let's say 9 over 2 multiplied by pi over 3. You can cancel the 9 with the 3, and this will give you 3 over 2 pi as an exact value. They are saying round to the nearest tenth, so this is approximately 3 over 2 pi will be about 4 point to the nearest tenth, 4.7. By this, my dear students, we come to the end of our lesson for today. Till we meet again, goodbye.